Hello ladies and gentlemen, welcome to part 2.2 of our test-driven development techniques video tutorial. My name is Vasily, I am a professional software engineer. In the previous video we started the implementation of instructor schedule class using Uncle Bob's test-driven development technique. This technique is based on just three simple rules. You are not allowed to write any production code unless it is to make a failing unit test pass. You are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. You are not allowed to write any more production code than is sufficient to pass the one failing unit test. Many of you probably did not understand what Uncle Bob had in mind when he defined these rules when you saw them for the first time. But now, after watching the previous video in this series, you already know how to put these rules to work in order to create software while writing the tests first. Now we shall get back to our system where we left it and complete the required functionality while using this technique. So we are working on driving lessons registration management system. In the previous part of these tutorials, we took care of the first requirement and ensured that instructors work between 8 AM and 4 PM and that students cannot register for driving lessons outside of these hours. Now we shall proceed to the next requirements and ensure that instructors can teach more than one student at a time. So the next test method that we will write, schedule lesson, attempt to schedule the same lesson, rejected. Okay, so if we try to schedule the same lesson twice, it should be rejected. So again, lesson equals, let's take the wanted lesson for example, and we know that the first attempt will succeed. And we would like to assert that the second attempt fails. Run the test. And we see that the new test failed. Well, it is only logical because there is no scheduling logic in the production code at all, and we need to add it. Alright, so we will start by making some list here that will contain the scheduled lesson, scheduled lessons. Great. And here we need to make sure that if this happens, then we return false, of course, but otherwise we would like to add to the lessons and return true. However, we need to ensure that we can schedule two lessons when they are the same. So the simplest approach to that will be for lesson. Okay, so we will loop through the scheduled lessons, and if we will find out that the lesson is equals one of the scheduled lessons, we will immediately return false. I think that will suffice. Let's run the tests. Oops, looks like I broke half of my tests. And here is one of the major advantages of Uncle Bob's method. Since I know that all these tests passed just a minute ago, I can be completely sure that whatever the reason for the failure is, it is somewhere in the new code that I added or the old code that I edited. So let's find the reason and fix it. One of the failing tests is the one that should reject if we attempt to schedule a lesson after the instructor ends his workday. Well, it is probably somewhere in these lines of code that the bug is hiding. So we would like to ensure that if start time is after instructor start time and before instructor end time, we return false. Well, no, we want to return false if the start time is earlier than instructor start time or end time is after instructor end time. Let's run the test and see if it fixes the problem. All tests pass. Let's take a moment in order to understand what just happened. I tried to introduce a new logic into this method, and along the way I had to refactor some existing logic in it. While refactoring that logic, I introduced a bug, which could be devastating for my production code and the entire system. However, since I had all those tests beforehand, I noticed that there is a bug like a minute after I introduced it, and I was able to go and fix it right away. That's the power of test-driven development in its full glory. Since all the tests pass again, according to rule number 1, we can no longer write production code and need to add some tests. Now we have this test that ensures that we cannot schedule the same lesson twice. However, clearly this is not enough. Therefore, let's add more test cases for this scenario. Schedule lesson and lesson overlaps on start, rejected. So what this test will ensure is that if we try to schedule a lesson that overlaps the start of one of the existing lessons, it will be rejected. So lesson 1 will be valid lesson with a start date time. Let's say it +1 and end +5. And the second lesson will be the same, but it will start exactly when instructor starts and will end before the previous lesson. Right. And now we would like to schedule the first one, and then we would like to attempt to schedule the second one, but the result of this attempt should be false. The system should not allow us to schedule the second lesson. Run this test and it fails. So we need to go and fix the production code. Currently we only check that the lessons are not equal. However, now we would also like to make sure that they're not overlapping on the start. So lesson get start date time before scheduled lesson start and lesson get end date time after scheduled lesson get start. Alright, I think that should work. Yes, it works. So next test case will be very similar to the one we have now, but the lesson will overlap on end. and any overlapping lessons should be rejected. So the first lesson will start here and end here, and the second lesson will start after the first one, but will end after the first one ends. And in this case we expect that the lesson will not be scheduled as well. Let's run the test. The test fails, so we can go and fix the production code now. Cool, so we need to add additional condition which will be similar to this one. Let's reformat the code a bit for readability. No, that will be not good. Okay, let's keep it like this for now. And then just... Okay, so we want the start date to be before the scheduled lesson end date, and the end date to be after the scheduled lesson end date. If that's true, then we should return false from this method and the test will pass. Let's run the tests. Cool. Okay, next test case will be very similar to those ones, but it will ensure that if the lesson is contained inside scheduled lesson, it will be rejected. So the first lesson starts at +1 and ends at +5. The second lesson will start at +2 and end at +3, and if that's the case, the second lesson should be rejected. Let's run the tests. Well, this test failed, so we need to add this condition to the production code. What we would like to ensure is that when the start date is after the start date of the scheduled lesson and the end date is before the scheduled lesson end date, right? Then this new lesson cannot be scheduled because it is contained within the already scheduled one. That should do. Yep, it works. And what I think will be the last test case in this context will ensure that if the lesson, the new lesson, contains an already scheduled one, it will be rejected. So it overlaps, but the new one will contain the already scheduled one. So the first is +1 to +5, and the new one starts before and ends after. It should be rejected. Alright, let's run the test. And the test passes. Well, honestly, I did not expect this to happen. However, tests don't lie. If this test passes, it means that some of the logic that we have already written takes care of this test case as well. Very nice of it. We have already taken care of instructors' work hours and also of scheduling the lessons in parallel. So now we need to take care of the fact that instructors do not work on weekends, and also that instructors have additional vacation days. When I think about it now, if I will build a system for accounting, those two cases will be different, because the implications for the salary will be different. However, from the perspective of our current task, lesson registration system, those two cases are essentially the same. It doesn't matter for the purpose of our system whether the instructor is on vacation or on a weekend. This day, instructor does not work, period. So we can merge those two requirements into a single one. How will the instructor schedule class know about instructor's vacation days? This is clearly not its responsibility to know that. Therefore, we will need to create additional class here. The class will be called instructor vacation checker, for example. Let's move it to the second tab where the production code is shown and close the project navigator. We will probably want this class to be mocked for our test. Right, and this mock should become instructor schedule constructor parameter. And since the test will not compile like this, we should go and fix that. Oops, no, that's not the name I would like it to have. And yes, please create a field for this one. Great. And now we would like that whenever this mock is called, is instructor on vacation, and that will be any, then return false. So by default instructor is not on vacation. And we need to create this method because the test does not compile. And let's make it local date and not local date time, and we'll take care of that in a second. And here we find ourselves in a very interesting situation, because this method is a production code, but according to Uncle Bob's first rule, we are not allowed to write any production code unless it is to make a failing unit test pass, and we don't have a unit test for this code. So either we switch and start writing unit tests for instructor vacation checker class, or we should eliminate this production code in order to proceed with the old class that we were testing. I definitely don't want to start writing unit tests for this new class until I finish with the old one. Therefore, the trick that I often do is to turn this class into an interface and keep it like that for a while. I do not have any real intention to keep this class as an interface long term. Eventually I will turn it back into a class and write the implementation while testing it all the way along. However, for now, this workaround of defining an interface allows me to proceed with my old unit test and not write any production code without unit testing it first. It is a nice technique to know and use in languages that allow for it. Alright, now let's add the actual test that will make use of this new mock. Schedule lesson instructor on vacation rejected. Okay, so if the instructor is on vacation in this day, the lesson should be rejected. And in order to set it up, we need this mock any, then return true, instructor is on vacation. So schedule a valid lesson and assert that the result is false because instructor is on vacation and the scheduling attempts should be rejected. Run the tests and this new test failed as expected because currently our production code does not make use of this instructor vacation checker at all. Therefore, we would like to add this check to preconditions, right? So if vacation checker. And let's fix the name of this method. Is instructor on vacation, and we need to give it a local date. So we'll get the date from the lesson, get start date at time to local date. If it's on vacation, then we return false. Let's rerun the test, and everything passes. You might have noticed that I hesitated a bit when writing this condition, get start date, because the lesson will have start date and end date, and potentially the start date and the end date can be different days. Since I'm using just the start date, it means that there is some implicit assumption in here, and the assumption is that the start day and the end day of the lesson is the same day. As we said earlier, we don't like implicit assumptions, we would like to make them explicit. Therefore, we need to add test that ensures that start date and end date of the lesson is the same. But before we add this test case, we need to get the test related to instructor on vacation complete. This test case ensures that if the instructor is on vacation, the lesson scheduling will be rejected. However, we also need to ensure that correct date is passed to instructor vacation checker. Right, so what we'd like to do is that introduce an argument captor for the class local date and verify that this method was called, and also assert that the value that argument captor captured is the same as the date of the valid lesson. Very nice, it works. We've been talking for more than 20 minutes now, which means that it is a good time to make a pause and summarize this part. In this video, we saw how to implement the second requirement and ensure that instructors can teach more than one student at a time. And we also saw how to implement the third and the fourth requirements together and ensure that instructors can have vacation days when they do not work at all. In the next part, we will complete the implementation of instructor schedule class and will perform the most important step in test-driven development, which is to refactor the code after all the tests pass. So, I hope you found this video interesting and useful, and if you did, don't forget to like it and subscribe to our channel. See you next time, goodbye!